Yay!
Yay! Well, I thought I was about done, but there was one more problem that I wanted to try, and it might be one of the more practical ones. Here's the idea. Suppose I have a projectile, and I want to launch this thing, and it goes off with some initial velocity, right? And then it comes down to hit some target. And it's actually not going to matter eventually if this thing is above where you launched it or below. Maybe you're firing something off of a cliff. The idea is, suppose you know what V is, you know how fast it comes out of your cannon or whatever, and you know the R to the target and you know the H to the target. What you don't know is how to aim the gun, right? What you want to solve for is the theta. So let's do that. It turns out it might be just a little bit tricky. Okay, so how do we start? Like we usually do, we say R is VI in the x direction times t, so that's just going to be V cosine theta times t. And then the H, if it's positive, that means the thing is going to end up above where we launched it, and that's going to be VI in the y direction, so that's V, I'll just call it V. V sine theta times t minus 1/2 gt squared. Okay, cool. So we've got that. So what we want to do is do our usual recipe of trying to figure out how long the thing is in the air. And then we plug it back in. Well, normally we'd plug it back in to solve for r, but now we want to solve for theta, right? So the first thing I want to do is eliminate t. So what I'm going to do is solve for that t. T is r over v cosine theta, and I'm going to plug it right there and right there. All right, let's see what we get. It's going to be a lot of algebra. All right, but it's kind of a cool result. H is going to be v sine theta times r over v cosine theta. All right, that's the first term. And then I'm going to have a minus 1/2 times g t squared. Okay, so it's going to be an r squared over v squared cosine squared theta. Okay. The problem is that what we're going to want to do, H is something that we know, R we know, and let's say V we know. The problem is I got to find some way to solve this for theta. All right, well, let's just, let's go one more step, see if anything looks good. This is going to be, notice the V's go away, so it's just going to be R tangent theta minus g r squared over 2v squared cosine squared theta. I mean, maybe that's a little bit cleaner. Oh, but look at this. What can we do? This is h is r tangent theta minus g r squared over 2v squared 1 over cosine theta. All right, here's something that's not commonly used. I've only had to do this maybe a handful of times. 1 over cosine squared. Do you remember? That's also called secant squared. I can write it like that. What is that? What possible advantage is that? Well, if you dig down deep into your bag of tricks with trig identities, you might remember there was one for tangent squared and secant squared. And it's a rare day when you have to dig down that deep into trig identities to solve something. Let this be one of those days. So here's what I can do. I can call this r tangent theta minus gr squared over 2v squared, and the identity is secant squared is just 1 plus tangent squared. All right, cool. 1 plus tangent squared theta. So I can write it like this. Look at this. I guess this would be a minus, right? Multiplying that out. So I got my r tangent theta, and I got my minus gr squared over 2v squared. And then I got the same term times tangent squared theta. Oh, why we did this is, oh, and this equals our h. Why we did this is because now this is a quadratic in tangent theta, right? That's a little bit odd, but it's all right. Tangent theta is just something that we don't know. It could be an x. So rearrange this to write it in a quadratic form, right? So here's what I got. And that first coefficient in front of the tangent squared, I want to make that positive. That's sort of the rule. So I've got gr squared over 2v squared tangent squared theta minus the term with just tangent theta is r tangent theta. And then I'm going to have a plus gr squared over 2v squared plus h, because that's sort of my constant term. There we go. There's my quadratic equation. So I have my coefficient a is the thing in front of tangent squared. My coefficient b is just minus r. Right now, that's kind of cool. And then I've got a constant. It's kind of a complicated constant, but whatever, it's just a constant. To make the algebra a little bit easier, I'm going to multiply everyone through by the coefficient. I'm going to make the coefficient a equal to 1. So I'm going to multiply everyone by 2v squared over gr squared. That'll just make, I think, the algebra turn out a little easier. So here's going to be sort of my final quadratic equation. Tangent squared minus 2v squared. Ooh, look, I got an r over a gr squared. So what's going to happen is that r goes away. Bloop. Tangent theta. Plus, look at that term. The first term, if I multiply by 2v squared over gr squared, that just cancels that thing out and becomes a 1. So this is just going to be 1 plus 2v squared h over gr squared. Okay, believe it or not, that makes things just a little bit easier. Okay, so my a coefficient is 1. That's neat. I got my b coefficient, and I got my c is that constant right out there. So what I can do is now I can just basically just solve the quadratic equation, right? Neat. Except I've run out of room. Okay, next page. Bloop. All right, so here's what we're going to have. Tangent theta is equal to, all right, minus b. Unfortunately, let me just so I can keep track of it, let me write the quadratic again. Tangent squared theta minus 2v squared. You can go get a snack while I write this down. Tangent theta plus 2v squared h over gr squared plus 1 equals 0. Okay, we're back. So tangent theta, the thing we want is minus b. Okay, so that's going to be 2v squared over gr plus or minus the square root of b squared. Okay, so that's going to be a 4v to the 4th over g squared r squared minus 4ac, right? So 4, well, a is just 1, so this is just going to be, I've multiplied the c thing times 4, so it's just going to be 8v squared h over GR squared plus 1. All right, well, there we go. Over, can't forget over 2a. So all this is over 2. Well, we're almost home, right? So tangent theta, the tangent of the angle we're interested in is just going to be, let me distribute that too, v squared over gr plus or minus the square root. Now, when I bring the 2 inside of the square root, it becomes a 4, right? So that just knocks that 4 out. So this is just going to be v to the 4th over g squared r squared minus, let's see, I bring that 2 and it becomes a 4. 8 divided by 4 is 2. 2 v squared h over gr squared. Oh, I remember. I didn't put my, I didn't multiply my 4 in by my 1, so I got a plus 4 up there, and now when I divide out the 4, I'm going to have a plus 1. Okay, so, I mean, this is kind of it, right? Here we go. How about that? That looks like a mess. But the point is, we've sort of completely solved the whole thing. If we know if it's a cannon or something, right, we'll know our muzzle speed, our velocity out of the gun. That's our V. R, this is the horizontal range to the target. H, how high is the target? If it's a negative H, well, then you would just make this thing. If it's down below where we launch, we would just make that plus. You just switch the sign. And then we just add 1 there at the end. So if you plug all these numbers in, what you're going to get is the tangent of the angle that you should point the gun. Notice it's a quadratic, right? It's a plus and minus. In general, you're going to get 2 angles. There's sort of a lower angle where the thing goes more directly to the target, but then there's like a higher angle too. There might be 2 possible ways. If I launch something, maybe I want it to hit right there. There might be a way where I can launch it at a low angle and it gets there. And then there might be some other angle that goes a whole bunch higher, but still comes down and hits the target, right? So that plus minus is going to get you both of them. That's kind of cool. For example, if you plug in, what did I use? Just to verify, the V is like 50 meters per second. R is 100 meters. H is 20. So if we're trying to hit something 20 meters high and 100 meters away, and you're launching at 50 meters per second, what's the angle that you have to aim your gun? If you plug all that stuff in, what you get is theta turns out to be, you get 2 values for tangent. One of them turns out theta is 78 degrees, and the other one theta is 23.4 degrees. Cool, so those are the 2 different launch angles that will eventually go and hit the target. You can also go back to the problem that we did, was it last time? I think the last one, where we were launching something off a cliff. And in that case, the H was below. So what you could do is go back and plug those numbers in, switching the sign on that H, and verify that we get the angle that we assumed in the previous problem. Everything should work out fine. So this is an example where we find the angle in order to hit a target. And what's cool is that we get 2 angles out of it. So this is it was kind of a lot of algebra, and it was hard to find those angles. But we've just sort of completely solved the problem, right? So for any V, for any R, for any H, we can find the angle to hit the target. So kind of cool.